Alright guys, I am very sorry that I was not able to be into school today. Late last night I found out my car wouldn't start even when we tried to jump it. Still wasn't going, so I will be running around, getting a tow, trying to figure out what's wrong with my car, and trying to arrange transportation for the rest of the week if it's serious. So what I'm going to do is walk you through the first 2 pages of the Part B notes. Check Schoology for my message on kind of refreshed timeline and everything. But this video will get us at least a start. If there are any questions, obviously when I get back we'll talk about them. But hopefully this gets the ball rolling, and we can, not just waste a whole day of class. So the biggest thing in Part 2, Target 2B, is that now we're going to start finding these characteristics algebraically rather than just being given a graph and find them. So let's start with holes. We know a hole is a point where the rational function does not exist, and what causes this in the equation is when a factor cancels in the numerator and denominator. So you can see here holes occur when the rational function is undefined because both the numerator and denominator would be 0 for that x value. Holes are points and must be written as, and we talked about this in the notes, as ordered pairs. All right, so they must be written as ordered pairs there. So long story short, what we really mean is if there is a factor in the numerator that cancels, what you're doing is you're removing a value that would cause the numerator and denominator to be 0. And so then by removing that, you are removing that value from existing in the function. So let's take a look at the first example. Now the nice thing about this first example is you can notice that the numerator is completely factored. You have 3 binomial factors here, and we have 1 binomial in the denominator. Now we can clearly see, if we wanted to, we could put this in parentheses. You don't have to, but just so you can see that we have the same exact binomial in both the numerator and denominator. Well, when we are dividing something by itself, they cancel out. So x minus 1's cancel out, and that would leave me with just x minus 4 over x plus 5. All right, and the issue with this is 1, the x value of 1, would cause both the numerator to be 0 because this middle factor would be 0, and the denominator because that's all it is there. So what we have to do is take that factor and do just that, set it equal to 0, and then the x coordinate of your hole is what we get when we solve this for 0. So this here is the x coordinate of the hole. All right, so we now have the x coordinate. The question is, how do we find the y coordinate? Well, just like we've done so many times, if I know one variable of a 2-variable equation, I can substitute for that one variable to find the other variable. So now I will take the remaining function here, f of x, which we know what fx says, y, and I'm going to replace x wherever 1 for x wherever there was an x. So by doing this, I am now going to find the y coordinate, the range value for my x coordinate of 1. So as I simplify this here, I get -3 times 6, and we are going to get a range value or a y coordinate of -18, which means my hole is the ordered pair 1, -18 would be the answer there. All right, so pretty straightforward. If anything cancels, if factors cancel, numerator and denominator, then we set that factor equal to 0 and solve for x to find the x coordinate, then substitute for x back into the simplified equation after it's been canceled and solve for y. It becomes a little more challenging here when the numerator is not factored. Now, x squared minus 7x minus 30 should not be a difficult quadratic to factor because you can see our leading coefficient is 1. So we should be able to automatically factor this into 2 binomials. Because a is 1, we know that the leading term in each binomial is x, and then we're going to look for two numbers that multiply to negative 30 and add to negative 7. If you need to pause the video to think about that and you don't want to see me write them, probably didn't even give you time to pause, but it is what it is. So you can see that once I factor the numerator, I now have a binomial factor that's the same. So x plus 3 will cancel, x plus 3 will cancel, leaving me with just f of x equals x minus 10. All right, so that's now my simplified equation after I'm canceling. So let's go through, and now we can do the same thing we did before. We take our canceled binomial, set it equal to 0, and I get x equals negative 3. So that is the x coordinate of my whole. And then I'm going to come back again in the simplified function here. One, it makes your life easier. Two, if you plug it back into the original, it's going to cause the denominator to be 0, which would cause the whole thing to be undefined. So I'm going to take negative 3 minus 10, and we're going to see f of x equals negative 13. So then my whole would be negative 3, negative 13. All right. So hopefully that helps us understand how we find wholes algebraically. It is going to involve some factoring, which we talk about up here. And you can see these are the methods of factoring that we've learned to this point: greatest common factor, grouping, AC method, with grouping, and then obviously we've used synthetic division. The key is obviously that both the numerator and denominator must be factored before you determine whether there is a whole or not. Notice in the second example, it certainly doesn't look like anything will cancel with x plus 3 in its simplified form, but once we factor it, we see that we do have those binomials. All right, let's move on to x-intercepts, zeros, and vertical asymptotes. So these are all things we're familiar with, but we've been working with them only graphically. Let's now work with them algebraically. So the y-intercept, this is when we've been doing here. We substitute 0 for the x coordinate, right, and simplify. We always write it as an ordered pair. And the nice thing about that ordered pair is we know that the x coordinate will always be 0, and then the y coordinate will be the number we find. X-intercept comes from a 0. Remember that a 0 is the x coordinate of the x-intercept, and we're always going to write this as some number comma 0. Now to find that x coordinate, to find our real zeros, and maybe I should put that in here, right, real zeros, we're going to solve for x when and here's the key, the numerator, let's go back here, numerator is set equal to 0. When we are looking for zeros, we do not care about the denominator. The denominator has absolutely nothing to do with finding zeros. Only the numerator is finding zeros. So we set the numerator equal to 0 to find the real zeros of our value there. Now, the vertical asymptotes, this is when we care about our denominator. The vertical asymptotes come from setting the denominator is set equal to 0. If the denominator is equal to 0, the entire equation and expression becomes undefined. So that's why we care about the denominator with our vertical asymptotes. All right, so we got two examples here, one where everything is factored for us and one where we have to do some factoring on our own. So let's take a look here. So if I look at this, all right, if I put 0, so let's just go down the list here. Let's start with our y-intercept. All right, so to find the y-intercept, I'm going to take this function, I'm going to put 0 in for everything in x. So what that's essentially going to do is make this top negative 4, because 0 minus 4, 0 minus 1, and then 5, 0 plus 5. And on the bottom, it's going to be 0 plus 2 and 0 minus 3. So negative 4 times negative 1 is 4, times 5 is 20, 2 times 3 is negative 6. So this is going to be, what are we going to, negative 10 thirds. All right, so then my y-intercept is that's the y-coordinate, obviously. My y-intercept is going to be 0, negative 10 thirds. If you wanted to write that as negative 3.3 repeating, that would be fine as well. And then I'm going to shrink this because I wrote much bigger than I think I meant to. All right, so let me just kind of box that off there. So let's talk about our zeros and our x-intercepts. For those, we only care about the numerator. I care about what values will cause the numerator to be equal to 0. Let me go back and just label this here. So this is to find our x-intercept and real zeros here. All right, so what I'm going to do is I'm going to take the numerator, x minus 4 times x minus 1 times x plus 5, and I'm going to set that entire numerator equal to 0. Well, using zero product property, this is pretty straightforward. Okay, well, this could be 0 on its own. Right, I could have x minus 4 equal to 0, or x minus 1 equal to 0, or x plus 5 equal to 0. So we can see this would be x equals 4, this would be x equals 1, and this would be x equals negative 5. So those are my zeros. My zeros are those 4 numbers. So my zeros, let me just change colors again here. The zeros are just those values, 4, 1, negative 5. Right? My x-intercepts are just going to be an ordered pair with those 3 numbers as the x-coordinates and 0 as the y-coordinates. All right, so there's my y-intercept, my x-intercepts, and my zeros. So the last thing we have to talk about here is the vertical asymptotes. Now, we do the exact same thing we did with to find zeros and x-intercepts with the vertical asymptotes, except instead of the numerator being set equal to 0, we're going to take the denominator and set it equal to 0. All right, so you see x plus 2 equals 0, so x equals negative 2, or x minus 3 is equal to 0 using zero product property, and x equals 3. And these right here, guys, these are the equations of my vertical asymptotes. I have a vertical line at negative 2 and a vertical line at positive 3 for the asymptotes of this function. So there we go, y-intercept, x-intercepts, zeros, and vertical asymptotes. Things obviously are slightly more complex if we have to factor things ourselves. Again, this shouldn't be too bad because our leading coefficient is 1. So I can factor this to x times x in both binomials, and negative 5 and negative 4 are what we will have when we factor this. Now notice in both examples, nothing canceled. There was no factors in the numerator and denominator that cancel, meaning there are no holes here. We did that on purpose. Eventually you will have to worry about finding the holes and canceling first before you do all 4 of these things, but for right now we're just keeping it straightforward on these 4 characteristics here. So let's go through this again. Y-intercept, right? We're gonna set everything equal, set all the x values equal to 0. So that will be negative 5 and negative 4 in the numerator, and this will be negative 6 in the denominator. So that's gonna be wow, that's a coincidence. I'll be honest with you, I did not plan that out to my memory. So there we go. We got the y-intercept. All right, so let's talk about our x-intercepts again and zeros. Right, we're going to take the numerator and set it equal to 0. So x minus 5 times x minus 4 equals 0. I'll get x equals 5. I'll get x equals 4. So my zeros are 4 and 5, and my x-intercepts are 4, 0 and 5, 0. All right, last but not least, our vertical asymptote. Now this one is pretty straightforward there because there's only one binomial in the denominator, so it's just x minus 6 equals 0, so we can just add 6 to both sides, and we would have our vertical asymptote there. All right, so you can get started in the notes The notes are going to be, sorry, notes, I mean the homework. You can get started in the homework. The homework is going to combine everything together. So this third and fourth page that we haven't got to on horizontal versus slant asymptotes, and then finding our domain, range, and behavior, and essentially rate of change. That's going to all come from actually graphing it. You can see the last problem in the notes here is what the homework is going to look like. So while we don't have enough in this video to do everything on these in this table, you can at least get started on the holes, the x and y intercepts, the real zeros, and finding vertical asymptotes for those problems, and get a head start on getting that finished. If you got any questions, just make note of them and bring them to class on Wednesday, and we will talk about them. Thank you guys for your understanding, and I hope you have a great day.